All right, for this video, we're going to look at polar equations. And conics. So we're going to see polar equations that when they're converted into rectangular, they become those different conic sections we studied. So they're going to become, we already looked at circles, but today we're going to focus on parabolas, hyperbolas, and ellipses. So these are a little bit more complicated as far as the process to convert them to rectangular. However, the process is very repetitive, and so it'll be nice because we'll be doing the same thing over and over. So first, I'm going to go ahead and say, let's recall that x equals r cos theta, y equals r sine theta, r squared equals x squared plus y squared, and an alternate form of that is that r equals the square root of x squared plus y squared. Okay, so we're not going to be using all of those. Actually, we are. We're pretty much going to be using all those. We're not really going to be using this formula today. We're going to be using this one. There are multiple ways of doing this, and what I did is I played around with some of the problems. I came up with the process I thought was appropriate for us, and then this is what I'm going to show you guys. If you want to try playing around with making the substitution at a different point in the process, you are welcome to do so. This is not the only way to do these problems, okay? But I'm going to be consistent in how I choose to do them with you guys so that I will limit the confusion you might possibly have, okay? So bear with me on this first problem. It's going to seem like a really long, crazy process, but by the time you do it 5 times, you're going to feel more comfortable. So the first thing we're going to do is we're going to treat this kind of like the equations we had where it was like 1 over cos. We knew that to get it into something that we could substitute, we had to take what was on the bottom and multiply it to the other side. So we're still going to start with that step. We just have a little bit more going on in this denominator. So those cancel, and I'm going to go ahead and multiply that over here. So that r is going to distribute, and that gives us 3r minus 3 cos theta equals 1. And there's a whole lot of different ways you can do this next step, but what I'm choosing to teach you is to make the substitution now. So I'm going to say 3r gets replaced with x squared plus y squared underneath that square root sign, minus 3x equals 1. And then the goal right now is to get rid of that square root. And the easiest way to get rid of it, we're going to have to square something. We don't want to square the equation right now because that's nasty foiling. So what I'm going to go ahead and do is I'm going to take these two things and move them over to the other side so that when we do square each side, our job is a little bit easier. So I have 3 times the square root of x squared plus y squared equals 3x plus 1. And then I'm going to go ahead and divide the 3 over. So we have the square root of x squared plus y squared equals 3x plus 1 over 3. And now I can go ahead and get rid of that square root sign by squaring each side. So the left side was pretty easy. I know that when I square a square root sign, I get x squared plus y squared. But on the right side, when I square that, I need to write it twice. And then I need to FOIL it. So on the top, when I FOIL that, I get 3x times 3x is 9x squared. 3x times 1 plus 1 times 3x gives you 6x. And then 1 times 1 gives you 1. On the bottom, I have 3 times 3 is 9. And then at this point, I don't like this fraction, so I'm just going to multiply each side by 9. So I have 9x squared plus 9y squared equals 9x squared plus 6x plus 1. All right, now you're going to have to really pay attention to the directions so we know that for today at least, in the context of what we're learning, that these problems are going to be a parabola, a circle, a hyperbola, or an ellipse. And we have the general conic form, which we get just by making the whole equation equal 0. And we have the standard conic form, which happens when we do the completing the square process. So for most of these today, I'm going to say do general conic form. Make it equal 0 and be done with it. But sometimes I could ask you to put standard form, so you need to pay attention to the difference in those instructions. So for today, again, we're just going to make it equal 0. So I'm going to minus each thing over. So my right side equals 0, and the 9x squareds, those canceled out. So we got 9y squared minus 6x minus 1 equals 0. And now, so I've converted it into the rectangular form. It's recognizable, it's just the general conic form. Now I need to classify it and say what it is. So here I've noticed that my x squared term has gone away and I only have a y squared term, and the only conic that had that was parabolas. All the other conics had an x squared and a y squared term, so this is a parabola. And if I wanted to be more specific, I could say it's a parabola that is resting on its side. So it opens to the right or left. All right, example 2. So that last problem was kind of crazy with the process, but now we're just going to do that exact same process a second time. So hopefully this question will be a little bit more comfortable. So 4 over 3 plus 2 sine theta. Just like last time, what we're going to do is we're going to start off by multiplying by that denominator. So we have 3r plus 2r sine theta equals 4. Just like last time, I'm going to go ahead and make my substitution now. So I have 3 times the square root of x squared plus y squared plus 2y equals 4. Just like last time, our goal is to get this square root alone. So I'm going to subtract the 2y over. I'm also going to divide the 3 over. Just like last time, I want to get rid of the square root, and I'm going to do that by squaring each side. So the squared and the square root cancel out, x squared plus y squared. But on the right side, we have this whole set of parentheses being squared, so I'm going to write it twice. And I'm going to FOIL it. So negative 2y times negative 2y is positive 4y squared. Negative 2y times 4 is negative 8y, and another negative 8y, so that makes negative 16y. 4 times 4 is positive 16. And this is divided by 3 times 3, which is 9. So just like last time, we're going to multiply the 9 over to the other side. So we have 9x squared plus 9y squared equals 4y squared minus 16y plus 16. And then we're still going to do that general conic form. So I have 9x squared. This was 9y squared, but I'm going to subtract 4 from it. So plus 5y squared. I'm going to add over the 16y. I'm going to minus over the 16 to make it equal 0. So this time I can see that I was keeping my x squared and my y squared term. So that means that it is not a parabola. They are both positive, so that means that it is not a hyperbola. So my two options are that it can be an ellipse or it could be a circle. And since the coefficients are different, that means it's an ellipse. Since the coefficients are different, that would mean that like the left and right radius and the up and down radius would be different. And so that's what makes it an ellipse and not a circle. Okay. We're going to do almost the exact same problem as what we just did, but I want you guys to see what happens if we switch some of the numbers. So here we did r equals 4 over 3 plus 2 sine theta. Now we're going to do 2 plus 3 sine theta and see how it makes the problem different. So again, that first step is going to be the same. So multiplying this to get it off the bottom. So we have r times 2 is 2r plus 3r sine theta equals 4. So I just took the bottom and I multiplied it over here. Now I'm going to go ahead and make my substitution. Now I'm going to do some work to get that square root by itself so that I can square each side more easily. So I have 2 square root of x squared plus y squared equals negative 3y because I subtracted it over, plus 4. And I can go ahead and divide that 2 over as well. And I'm going to go ahead and square each side. So I have x squared plus y squared. Here I'm going to go ahead and write it twice so that I can FOIL it. So negative 3y times negative 3y is positive 9y squared. Minus 12y minus 12y gives you negative 24y, and 4 times 4 is 16, and on the bottom is 2 times 2, which is 4. And so I'm going to go ahead and multiply that 4 over to the other side. So 4x squared plus 4y squared and I'm going to go ahead and get it into that general conic form by moving everything over and making it equal 0. So there's no more x squared, so I've got 4x squared. I have 4y squared and I'm minusing 9 from that, so that's negative 5y squared plus the 24y minus the 16 to make it equal 0. So here's my equation. And when I look at these, it has an x squared term and a y squared term, so that means it is not a parabola. But one of those terms is negative, and so that means it can't be an ellipse, it can't be a circle. So that means this is a hyperbola. All right, so we'll do more practice in class just to see about recognizing those. But for the most part, this process, as you can see, is the same.